Okay, and now I think you can hear me. Hi, everyone. Thank you for coming to this session. My name is Alina. I work at Oracle on GraalVM. Super happy to be here. I was also here 2 years ago, I think, and we did a lot of work since then, so I'm happy to show you what we did. And as I've learned at CERN, I have way too much content, so I threw out some slides, and hopefully I will have more time to show you even more demos. So let's go ahead. This is me. If you want to ask any follow-up question, if you want to ask for demos, or if you maybe have some issue question about GraalVM, you can find me on any kinds of social media and follow up. And I work at Oracle, and specifically at Oracle Labs, which is an R&D unit at Oracle. If you remember Sun Microsystems, anyone in the room remembers? Yeah, so everyone, obviously. So Oracle Labs used to be Sun Labs. Then when Oracle acquired Sun, it became Oracle Labs. And we still have Sun emojis in our corporate Slack, fun fact. And I love open source and community. That's why I like coming to places like this. And I love both programming and natural languages. I'm afraid my Italian is very limited, but I would be open to learning more if you want to teach me some during the breaks. With that, let's go ahead and talk about GraalVM. Super quick 1-minute intro, just so we're on the same page what it is, because there are many big parts of our project. Sometimes people are confused what is GraalVM, what it can or cannot do. So in the end, it's a normal JDK, just like any other JDK of your choice, Oracle JDK, Open JDK. And we don't exactly remove things from the JDK, we just add things on top. So one such thing that we added is this ahead-of-time native image compilation, which you probably have heard about. This is where we can take your Java program and compile it ahead of time into a native executable. And the reason to do so is because when you deploy it, you can just deploy it on a machine that doesn't have a JVM, and it will run fully functional by itself. It doesn't need a JVM in the end. It's just a native application, but you write it still in Java. So that is one thing that we added. Another thing you maybe have heard at GraalVM is this polyglot VM. And beyond Java and JVM, there are way more languages that we can run. We can run Python, we can run WebAssembly, we can run JavaScript. Or if you want, you can implement even your own language by writing a Java interpreter and run it on GraalVM. So in the end, it's a JDK. We just add more things on top. So when it comes to Java, with GraalVM, you get to have this choice how you want to run your program, either on GraalVM as a JDK or on native image with this ahead-of-time compilation. And I like showing this slide because whenever I come to conferences, people like asking me this kind of tricky question, or so they think. And the question is, when should I not use GraalVM? They want to catch me, like asking this uncomfortable question. But my answer is always use GraalVM, always. But just choose for yourself which part, right? So do I want to stay on the JVM? Do I want to use GraalVM as a JDK? You can just do so and just run as your normal JDK. And the reason to use GraalVM in this context will be because we have a brand new, highly optimizing, very aggressive compiler. So by switching to GraalVM as a JDK with our own compiler, you can win somewhere between 10, maybe 15% performance improvement just on the JDK. And you might say, OK, this is not a crazy performance improvement, but at a scale, if you may be a big organization or maybe if you have very high load, this really adds up, and the migration there is very easy. It's just swapping your JDK to GraalVM. Or you can go in with this ahead-of-time compilation and have a native program, and that will give you fast startup, low memory usage, all the benefits of a native program. So long story short, when it comes to Java, you get to choose with GraalVM. It's never one way or another. Well, technically, there is one more secret third way of running Java on GraalVM that is called Project Espresso, and that is running Java on Java via our own Java implementation. But this is getting too much into the woods when it comes to more like common use cases. This is what you can do with GraalVM for Java. Now, very briefly about the history. So I mentioned GraalVM has been developed by Labs, the R&D unit at Oracle. And it might seem like a newer project to you, but we've been working on it in terms of research for many and many years. It all started back long ago in 2011 when Thomas Yurenko, our project lead MVP, joined Oracle and started working on this compiler project. And as you can see, we did a lot of work since then. And I like showing this slide because, A, I think it's a beautiful slide design. So I'm just happy what we did as a team. But also, I'm happy about all those accomplishments. And just to highlight a few things here, though they all are important, but just some of my favorites. So in 2019, we released our first GA builds. So they were also commercially supported by Oracle as a product. So 6 years ago now? And even though it was in 2019, back in 2018, even before we had our first GA release, the Micronet team already saw the potential in GraalVM and this ahead-of-time compilation, and they started introducing and even endorsing GraalVM as a platform even before we were GA with GraalVM. Then one more thing that I like, and my maybe favorite user story, is Alibaba, because they started using native image back in 2020 and have been happily using it in production since then. And why I like this so much is because native image is ahead-of-time compilation. It might seem like this scary, revolutionary, crazy way of running Java, but Alibaba has been running it in production since 2020, and they are very happy. And you can imagine Alibaba what kind of traffic and load they have in their system. And one more of my favorites here in 2022, Spring Boot introduced support for native image out of the box. Before it was experimental, but now it's fully supported, fully GA. And yes, you can build Spring applications with native image and safely use them in production. So super quick, and then we'll switch immediately into demo. How is it even possible to take something as dynamic as a Java program and compile it ahead of time? Because we know that when we run our program on the JVM, there is a lot of work going on, and there is a lot of dynamism. Many things are resolved at runtime when we actually run our application, and all of them come together. So how is this possible to compile it ahead of time? So when you run our native image command and give it your application, and the input has to be in the format of bytecode, so your jar or your class files, what will happen is that native image will look at your application, starting from its main entry point, and from there, it will try to analyze and find everything that is needed for your application to run, so discover what is involved in what the application is actually doing and what is crucial to perform the functions that your application is supposed to perform. So we will run this analysis, trying to find all the reachable things that are needed at runtime, and then we will ahead of time compile your application into this native executable. And because of this, sometimes native image is called an ahead-of-time compiler, but this is not the entire story. There is one more important part to it. As we are analyzing your application and discovering more and more about it, one more thing that we are doing is we are looking at your heap, and we are defining what is safe to initialize at build time. So you don't need to initialize those objects at runtime. And this way, we save you even more time and resources and memory by doing this at build time, as opposed to every single time at runtime. So ahead-of-time compilation and heap snapshotting, and in the end, we produce this native executable that is ready to start and has very minimal startup overhead. Now, this native executable will be platform-specific, so you need to build it for a specific operating system and for a specific architecture, but we will get to that in a second. With all the talking, let's look at the first demo. Yes, we are here. So maybe I don't need to rerun this because I already ran this. As you can see, my Java version is GraalVM for JDK 24. You might know that this is not released yet, but it will be released in something like 8 weeks from now. But you can already try it out with our early access builds, and that is something that I'm actually doing. And what's fun, you can see that I was running Java version, and then I was writing native image version, and it looks almost the same as the Java command. So a fun fact and a fun tip here is, if you at any point in time lost about some flags or some commands that you can run with native image, the rule of thumb is we see native image and the developer experience of it. We want it to be as close to Java as possible. So if you want to build application with native image, you should be able, in most cases, to just swap your Java command with a native image command. So how would you, for example, run a jar on the JVM? You would do java-jar and pass your jar. So in the exact same way, you would do native image-jar and pass your jar. So if you cannot remember the flags or like the order or anything, you can just swap your Java command for a native image command. And our big goal is that in the end, it should work exactly the same. But let's run our app, and then we will take a look at it and see what it does under the hood and what is in our project. But a little teaser already, we can see that this is a Spring application. Now it starts, and it shows some scary warning from the recent Java versions that always give me anxiety when I run demos. But our application has started, and it's running on 8080, and it started in 2.5 seconds. So let's go ahead and check it out. One more thing that I need to add here, so this is running on a dedicated separate cloud instance, so hopefully this is not being interfered with by my slides or anything. This should be a nice, sanitized, clean environment. So let's go ahead and check the app, 8080, and the endpoint is translations. And it does seem like we might need to remap our ports, do we? 8080, add 8080. Oh, if only I could type 8080. Oh, it's already forwarded. Why doesn't it want to run though? OK, let's try again. OK, now all good. Remote instance, so needed to be remapped. So here we can see a little dictionary application running. Again, this is not Italian, I apologize, but this is a fun language called Swiss German. I don't know if you can speak it, but it's a very fun one, and I encourage you to take a look at it. Nevertheless, it's a dictionary application. It has our English translations and our Swiss German translations, and our application runs, but it has started in 2.5 seconds, which I think we could do better than that. So let's go ahead and compile with GraalVM a native image, and then we will take a look at the project. So as this is a Spring project, the general compilation command for Spring projects to native will be always like this: maven pnative native compile, or if you want to use other profiles for things like additional optimizations, etc., you can pass that profile of your choice. And then under the hood, we are here. Let me just zoom this out. So this is our project. We have our main application class, and we can see, go down. We can see that this is indeed a Spring project here. And then we have our controller where we have our actual endpoint, and we can retrieve our translations. And as a source here, we are using H2. So this is where our translations are being stored and retrieved from. So let's see how our compilation is doing. Our project is being compiled. One more thing that I wanted to point out is here is my POM XML for my project. And the interesting part for me here is I have my Spring dependencies, data, web, whatever. But what is interesting for me is this native Maven plugin over here. And as you can see, this is not coming from Spring. This is coming from our own team. This is the plugins. Those are the plugins that we developed for you to compile applications with native image. And the Spring team is kind enough to include our plugin into their projects as this nice unified interface and a facade to build applications with native image. Now, this is all building out of the box. There are no magic. There's no magic, no tricks here. One flag additional that I'm passing here is -OB, and this is enabling the quick build mode. So I'm instructing native image that I'm still developing my application. I'm in my development phase as opposed to deployment and production, and please make my builds faster. Now, this will not make a tremendous difference. It will not be like 2 or 3 times faster, but it will skip some of the compilation steps. It will not optimize for peak throughput in production just yet, because I'm still developing my application. So I just want my results quick as opposed to optimizing fully for production. And this is usually the step where, when I'm compiling this live on stage, people afterwards come to me and say things like, Alina, oh my God, this is taking so long. Why do those builds have to be so long? Do something about it. We don't have that kind of attention span. And I agree with you. I also don't have that kind of attention span, but check this out. So my project was maybe, what, like 5 classes that I myself wrote. And yes, I have my JDK, I have my Spring, I have all my dependencies. And in the end, it means that there is a lot of complexity and a lot of things going on in my project under the hood, coming from the platform, the framework, and the dependencies. So if you look at the analysis, a native image gives you this nice output as it looks at your application. What we see here is that it has found 33K reachable types, over 50K reachable fields, and 187K reachable methods, out of almost 300K total. So there is a lot of complexity in my project, and that is to make me productive as a developer. It's a very nice experience, also to make my application fast because of the JVM platform. But what this means is that there are many things coming together to make my Java project work, and that's why native image does need some time as it builds your project, but it offers you this trade-off where you can do all that work once at build time, and then you don't need to do this exact same work when you are running your application, because the JVM does pretty much the same things, but every single time you run your application, and we offer you a way to do it once, and then you don't need to do the same thing as you are running your app. Nevertheless, as I was chit-chatting, our application has been compiled in 1 minute. And granted, this is with the quick build mode flag, but without it, it would have been maybe 1 minute and 30 seconds. So it's still not too bad for a fully blown web Spring application also that is using and reading data. But let's run the native app now. So it's in Target and it's called Dictionary. So now it starts in just 148 milliseconds. And if we go to our endpoint, we can see that we are still able to retrieve our application and our translations from this app. And if we kill this and just explore a bit more what we got as a result, so this is my, where is a dictionary, freshly compiled application. Granted, this one is a bit bigger, so it's 120 megs. But if you want to have smaller application sizes, you can talk to me afterwards. There is an additional flag called -os. And if for you the image size is important, you can make it even smaller. But for me, I don't care about the image size. For me, this is fine. And this is my complete application. Everything that it needs to be running is already in that native executable. So let's go back to the slides, and let's talk about why we do this in the first place. So we saw that this application started much faster than the one on the JVM. It was 2.5 seconds as opposed to 148 milliseconds. And if you have ever tried native image, or if you have ever heard anyone talking about native image, probably you have heard that this is very good for startup, so good for things like microservices, serverless, etc. And you might be wondering, okay, I have a longer running application that I deploy, and then it runs for a very long period of time. So in that case, would I be using native image, yes or no? And because if I don't redeploy often, maybe startup times don't matter to me that much. Is there anything that native image can do for you in that case if startup doesn't matter for you? The answer is yes. So one more benefit of using native image will be lower resources usage. Since unlike the JVM, we don't need to load your classes, interpret, compile, profile, etc. at runtime, we don't need to do any of that work, and also we don't need to keep around the infrastructure for all of that work. So we don't need the JVM, we don't need the data structures associated with it. It's all compiled and optimized ahead of time. It means that you can have maybe 3x, 5x less memory usage on native image as opposed to the JVM. And I think this can be especially interesting if you're deploying applications to the cloud, where memory is usually expensive. So if you can have the same application, but using 3x, 5x less memory, this could be very good for you, either in the cloud or even in your own data center. Now, another interesting benefit of native image is that it has predictable performance. So I got this question the other day on social media: how does performance of native image compare for longer running applications versus the JVM? And the thing with native image is, if you were to imagine the performance profile of your application, let's say as a line or a curve, like peak throughput over time, for native image, it will be very stable over time. So as soon as it starts, and it's a matter of milliseconds, it will be high and it will be very stable over time. Unlike the JVM, where it needs to warm up, and then eventually there could still be things happening, such as GC can kick in, something new can be loaded, etc. It's never the case with native image because it's very kind of static and deterministic because it's all been ahead of time compiled. And we have users and customers who say that for them this is very important because they have some SLAs that they need to meet. So they need to know that at any single point in time, the application will give them this predictable peak throughput. Now, one more aspect of native image that I think is not maybe talked about enough is that it offers additional security benefits compared to running your application on the JVM. So there is nothing unknown that can happen to native image at runtime because we do not allow loading anything new at runtime. And then things like reflection and serialization, they work with native image, but they need a specific allow list from your side. So from your side or your library or framework, but you have more control and awareness over what is happening in your application, nothing unknown can happen unless you specifically grant access for those things to happen. And the last thing, there are some attack vectors that attack the JIT compiler specifically. So this is not possible in native image because there is no JIT compiler anymore. There is only a tiny little VM implementation called Substrate VM, but there is nothing to attack in native image from the JIT compiler perspective. And we talked briefly about packaging, but if you want to have smaller container images or smaller applications, this is also something that native image can give for you because we don't need the whole Java runtime to be able to run your application. And then doesn't matter which framework you like to use or what is the cloud that you are deploying, all of them have some nice integrations for native image, specifically around deployment and monitoring. So if you're starting a new application right now, it's very easy to use native image, and I cannot recommend you any particular framework. They all work with native image, and we love all the frameworks, so it could be any framework of your choice. Now, talking about frameworks and libraries, I want to briefly mention how they can work with native image, because I want to make this session practical. And if you will be deploying a native image application in production, obviously you will need to use your libraries, and there are some things there to know to be able to build the application with native image specifically and using libraries. And some of the limitations that I will be talking about come from the fact that we have built the new application ahead of time, meaning the runtime hasn't happened yet. And to be able to build it ahead of time, we need to do it under a closed world assumption. So we need to limit everything there is to know about your application to the build time, because we need to be able to perform all the functions. Nothing unknown can happen, so this can be only done under a closed world assumption. And this means that things like reflection, which are typically resolved and heavily defined at runtime, need to be known at build time. So how does it work with native image? And I want to illustrate this point on the example of Spring Boot, because they had to develop this kind of smart and interesting project to be able to work with native image. So how does typically Spring Boot work when you first start your application? When you start your application, it will pull all your class files and all the sources of configuration into one place, and it will try to pull them together and bind them in a way to build this kind of universe and understanding of your application. And all of this needs to be known at runtime when your application first runs. Now, what's interesting, native image does a very similar thing. So it also needs to look at your source code and all the different formats of configuration to pull them together and build an understanding of your project. But I think you can see this kind of contradiction here, because Spring typically wants to do this at runtime when you start your application. And native image does a very similar thing, but it wants to do so at build time, and the runtime hasn't happened yet. So to bridge this gap, they developed together with our team this project called Spring IoT. And this is a new project and a new build step when you're building your Spring application with GraalVM. And it will transform your application in a way that is easier for native image to understand. This means that this needs very little to no work from your side. It will just transform your application in a way that is more native image friendly. And as a part of that transformation, it will actually generate a bunch of files to assist that native image compilation. So one such type of files it will generate is actual Java source files. For example, it will transform some of your config into more kind of functional style config that some people also call very beautiful. I struggle to see that beauty, but it's definitely more understandable by native image. Then it will generate things like bytecode for dynamic proxies. And the last thing, it will generate so-called hint files. So those are config files for native image, instructing native image what needs to happen in your application in terms of reflections, serialization, proxies, GNI, etc. And if you want to quickly assess, will your existing project work with native image or not, as a first step, I would always add our Maven and Gradle plugins and just try it compiling. But if you want to do a very quick assessment, like 1 minute one, specifically dependencies are typically the complicated part. So if you want to know if your dependencies will work with native image, we have this very nice page on our website called Ready for Native Image. And this is a very long list, something like over 200 projects of frameworks and libraries that are known to be working with native image and continuously integrating and testing to ensure that they are compatible. So there are many, many things here. If you want to know if you can use, I don't know, OpenTelemetry or something, you can just do Control-F on the page and see if your library is here. If it's not here, it might still work, but this is maintained by the community, so this list has been reported by the community as known to be working with native image out of the box with no effort from your side. So going back here, this slide will look a bit scary, but I will see if I can go over it quickly. So let's say you want to use some library with native image, and it has those more dynamic Java features, such as reflection, which for native image means that they need to be configured at build time. So how do you make libraries work with native image? And there are many bullet points here, but each bullet point is a complete solution, going from the best case scenario to a scenario that is maybe a bit less fortunate and requires a little bit more work from your side. So how can you use libraries, and especially those that, for example, heavily do reflection with native image, going from the best case scenario? So the best thing that can happen is, and we see more of this lately, when new libraries appear and they are written from scratch in a way that is more native image friendly. Let's see if I can open this one. So this was a post saying, hey, I developed this new library and it's GraalVM compatible out of the box. So if you are using newer libraries that are like this is the best case scenario. They will just work because they are designed this way. But obviously, there have been many libraries that have been around before GraalVM and native image became popular. So what to do in that case? Now, for existing libraries, the absolute best thing, and I recommend this if you're a library maintainer or if you are maybe in touch with some library maintainers, the absolute best thing is if a library includes config for native image within the library itself. So as an example, the demo that I was running previously, it was using H2 as database. And I like showing this demo because in the past, I had a demo where things would not work with native image because there was H2, and it will compile, but it will break at runtime. But now this is not an issue anymore, because if you look at the actual H2 source code here on GitHub, you can see that there is a folder under meta-inf native image, and it includes this file called reflect.config.json. And it's a long file that instructs native image to make those things visible, editable to your application. And this ensures that native image can build an application correctly, and this is not something you need to worry about. Also, this specific location, native image knows to look for libraries under this location to look for those config files. So as a library maintainer, this is the absolute best thing that you can do for your users, for your library to be compatible with GraalVM. But also, we realize that maybe not libraries are there, not all of them have introduced native image support yet, or maybe they still need to get to it. So what to do if your library doesn't have config within the library itself? Now, you would think that there are many libraries in the Java ecosystem, and we know all what they are. So it would be nice if there existed something kind of like Maven Central, where we could have this config stored in a centralized place. And then let's say if I want to use, I don't know, Netty or something, I can just pull config from that kind of Maven Central. So we had the exact same idea, and that is why we created this repo on GitHub with metadata for all the libraries. And if you go inside the folder, again, this is a very long list of libraries, where each folder is a bunch of JSON files for that specific project that includes config for native image. Better yet, I mentioned our Maven and Gradle plugins, and they are instructed to automatically go to this repo, and if you are building a project that has dependencies, they will pull config from here automatically. So again, all the things that are here also will work automatically without you even needing to know about it. By no means, this list is not yet complete. I would say that all the main kind of mainstream Java libraries are already supported either through the source code or through this repo. But if you are a maintainer or if you would like to contribute to this repo, we can certainly use more help and extend this. Now, I hope that you will never need to go beyond those 3 first bullet points where things are resolved for you automatically one way or another. But let's talk about less fortunate scenarios where there is no config in the library, there is no config in our GitHub repo. So what to do in that case? Now, that depends on whether or not you are using a framework that is working with native image. So those frameworks are the main kind of Java frameworks would be Spring Boot, Micronaut, Quarkus, Helidon. They all work with native image, and they all offer some kind of support for native image, and for those cases where you want to use a library that is not yet compatible. So I will illustrate this on the example of a different Spring Boot application. This one, native Spring Boot. And let's say we want to have maybe a rather weird case of reflection. Let me just close all of this. So let's say we want to read this message field from the message class, the one over here. And maybe we are doing it in a slightly less obvious way here as we are passing the class name. And this is done to try and outsmart native image, because if we just normally pass the class name, it would have been able to detect it even as a reflection call and make this work. So we are intentionally confusing native image. So how do we make this thing work? I already have my annotation here. So to make this work, because I'm on a version of a Spring Boot that is compatible with native image, so 3.0 and higher, I have this reflection annotation here. So I can say register reflection for binding and pass that place where it should occur. In my case, it's message class. And Spring, as a part of that Spring AUT phase, will generate configuration to make this call available for me. It's a matter of adding the annotation. Granted, this is still not very enjoyable to write those annotations manually, but still it's a nice programmatic way to generate hints for native image in case things do not work out of the box. And again, Spring offers even more ways of doing the same thing, gives you different ways, more flexible APIs. Another way that I like is using this runtime hints registrar API. And here we're trying to load resource, and for that we need config. And this API, I like it because it's more flexible. So we are doing hints resources, but in a similar fashion, we can do hints reflection, GNI, proxies, etc. So we can use this API to programmatically generate hints for our application. And this can be useful, for example, if you're on a version of a framework, such as I said, Spring Boot 3 and higher, where you have programmatic support for native image configuration, but maybe you have a library that is not compatible, such as, I don't know, you work at a bank or something, and you have internal library, and there is no config for it out there in the public, in the ecosystem. So this could be a nice way to programmatically generate config. Now, getting back to even less fortunate scenarios, so let's say you don't use any conventional frameworks, or maybe you use an older version of a framework, but you still want to use native image. What to do in that case? In that case, you can use the tool that comes with native image. It's called tracing agent. And the way this works, you can run your application on the JVM with our agent attached to it. And you need to execute the workload to instruct native image what is supposed to happen at runtime. So for example, you need to run on the JVM and make that reflection call that I had in my application. And our agent will look at that call and it will generate automatically this JSON file for you. This does mean that you need to do this work manually, but if you have no support from your framework or library, at least you can run the agent and you can have those files generated for you in the automatic or semi-automatic way. And the last option that I hope you will never have to get to, but just for the sake of completion, you can always write those JSON files manually. For example, I know I have one reflection call and exactly where it needs to occur, so I can just write it as a JSON file. So hopefully, if you especially are starting a new application, you will never need to go beyond those first 3 bullet points. But in general, those are your tips for using libraries with native image and overcoming those potential challenges with things like reflection. Now, going back to more fun things, I love talking about performance because I'm working on a compiler team, and for us, performance is a topic of great pride and interest. In the past, we used to always say if you run applications on GraalVM as the JVM and it's slower than on OpenJDK, report this to us because this is a bug. This should be never the case that something is slower on GraalVM than on any other JDK. So we take performance seriously, and we have this big vision of IoT at the speed of JIT. So despite what many people think, we want to make all applications on par or faster on IoT than they are running on JIT. So let's see if that's possible. For that, let's go back to our previous dictionary application. And let's see if we can benchmark it and see how fast it can run on GraalVM. Dictionary, and let me close all of this. So for the sake of saving time, I will use a bunch of scripts to benchmark our application on the JVM and then on native image and compare the results. And our benchmarking setup will be the following. So this is running on C2, and C2 is your default OpenJDK compiler. And we will run our application, the dictionary app, on the JVM, and we will attach the tool called PS Record because we also want to track memory and CPU usage of all our benchmarking cases. Then we will start our app. We will wait 5 seconds to give the JVM a chance to actually start with a benchmark. And then we will send 500,000 requests used by the tool called Hey, and then we will compare the results across our setups. So let's go, and this will be bench JIT C2. So now this will start and run. As it runs, I will say that by no means this is not a proper scientific benchmarking. This is very quick and dirty benchmarking for the sake of a conference talk. Proper benchmarking will take you hours and hours and a very advanced setup, but hopefully it will be educational in terms of IoT versus JIT. Okay. So our application ran on the JVM, and we can look at latency. It looks kind of OK to me, but I prefer looking at peak throughput, so requests per second. And here we are at 53.7K requests per second of peak throughput. So do you think it's fast or not? You can just shout. OK, people shrug. I kind of agree with you. It's hard to make those general conclusions. Let's compare with native. So this was the JVM. Let's get ourselves another tab, and let's do bench native. So this will do the exact same thing, wait 5 seconds, even though it doesn't need to wait, but we are just waiting because we were waiting for the JVM, and we will send the exact 500,000 requests to the native image version of the application. So who thinks this will be faster than the JVM? Like half the room, maybe, but you know that I work on GraalVM, so I could have done some nasty tricks to kind of make it look faster than the JVM. Let's see. OK, we got the results. Let's compare side by side. This was 53K, 53.7. This was 44. OK, not so good. Here, I could have said that, the JVM is the beast. It's very hard to beat it at its own game. Like, it's a piece of engineering masterpiece. And it is true. But I do think that we can do better. So let me get one more tab, and let's do one more round, and let's do native optimized. Now, I have yet another native version of the application, but with additional optimizations in place. I have been told already that I only have 10 minutes left, so I will try to speed up. There are 3 key things that are different in this application. It has PGO, so I have collected profiles from my native application, and I have fed them back into native image. And this is similar to the profile that the JVM does, where we are building an instrumental version of our application, collecting profiles, so seeing which parts, which methods, loops, etc. are hot. And then we are building yet another version of the app with those profiles. And this way, native image has awareness of a runtime behavior and profile of your application. So in a similar fashion as the JVM profiles your application as it runs, only we're doing the same thing ahead of time. Then in this version, we also have G1 GC. There could be different GC strategies, but in general, for native image, G1 is probably the best GC for peak throughput. And one last little thing, I use the flag called mwork native. So this instructs native image to build a native executable that is tailored to a specific machine where it's being built on. It's always platform-specific, but this is also specializing for the specific hardware features of the machine, making the most out of them. So let's compare side by side. And here we see the peak throughput was 53.7K. Here, native image out of the box, it was 44K. And then with the additional optimizations in place, it's 60K requests per second. Now, this is a very minimal benchmark. Obviously, you can do things more scientific. You can have different endpoints. You can replicate possible user behavior more precisely. But I hope this gets along the point that you can have a very good peak throughput with native image if you take the time to apply those additional optimizations. If you don't care, out of the box, you still get good peak throughput. Additionally, we have an ML model in native image. If you don't want to collect profiles and do this 2-step job, you can have profiles in place with this ML model that will give you 6-8% better peak throughput out of the box comparing to not having any profiles in place. But I was also promising you resources usage, so take a look at that. I mentioned that native image is very good when it comes to reducing memory usage and CPU usage. So let's see how our benchmarks were doing here. Let me close this. And the way to read this is coming from PS record. The way to read this is the vertical red lines, that is CPU usage, and the horizontal blue line, that is memory usage. So the first scenario is the JVM, and we can see that the CPU is quite busy in the beginning. And then when we receive the load, it basically goes through the roof because there is so much work to do as the JVM actually see that your application warms up and it needs to optimize it for that specific workload. Now, native image, remember how I told you that it waits in the beginning because this is how our benchmarking setup is designed. But it's basically idle and it's ready to go. It's just because of how we designed our benchmark, it needs to wait. So we have the exact same setup as with the JVM. And for memory settings, our application had the exact same memory settings in all 3 scenarios. But again, with the JVM, it went even higher because we got some load. Then native image out of the box has, I would say, the minimal possible memory, but we probably could have tuned it even further down. And then with G1 GC, we see that we have slight increase in memory, but we have much better peak throughput with this version of a native application. And in general, this is our kind of observation that you can typically always trade off memory for peak throughput. So if you want to have better peak throughput, you need to kind of give something and sacrifice something. And in this case, this means more memory. But this is the resources saving profile that you can have with native image. Now, I also promised you monitoring. So let's see if I can quickly switch to that demo and show you a monitoring application. So for that, we will use, again, a Spring application. And this one will be using the micrometer module to make monitoring and observability possible for our native applications. Let's see if I got this. And this is somebody else's application. So I have a bit of anxiety about running their setup. Let's see. So this looks promising so far. So this is starting my observability stack. And then we will actually start our apps to see how we can trace and monitor our native applications. And I have them already compiled for the sake of serving time. So here you can see that this server, the green one in my shell, green, that is native executables. So it's actually already compiled. Let's start the server. And we will also start a client application. So it can talk to the server, and we can observe and monitor our entire system. So again, this is also compiled already as a native application with GraalVM. So immediately we can see that the client is sending requests to the server. They are communicating. And then if we go to our observability dashboard, we should be able to see them communicating and trace latency and things like that. Do you also want to be remapped, I think? Let's try. 3,000. Yep. OK, dashboards, logs, traces, and metrics. Now, this one might take a minute or so to propagate the logs into our dashboard. But the system is already on because, for example, we can track the latency times. And this is all running as native image applications. And we already have some data coming into our monitoring system. OK, perfect. We already have the logs. So here what we can do is we can trace each individual request between our client application and our server application. And we can see that the client sends a request to the server to retrieve a user by user ID. And then we are getting the username. And we can see latency times and how this whole system comes together. And this is a nice unified way to monitor and have observability into your applications. So this is coming from Micrometer, but similar solutions exist in all other frameworks. Again, this is Spring Boot, but also Quarkus, Micronaut, Helidon have something similar. And again, if you're deploying applications to the cloud, look at your cloud providers. I know for sure that Oracle Cloud and Azure have specific native image monitoring capabilities on their cloud platforms. Now, with that, let me just go to wrapping up. One more thing that I probably want to show. So lately, we see a bigger and bigger trend in people looking at native image in terms of having a greener way of running Java applications, because A, it's the right thing to do. So if you can run your application but consume less energy, less memory, less CPU, that will be helpful. But also in many industries and countries, there are new government regulations to see if you can run your applications in a greener way, consuming less resources. And here, as a Spring Pipeline example, we can see that native image under a constant load still uses, I would say, 1/3 less electricity than a JVM version, because again, we have less work to do at runtime. With that, best practices, if you want to build for different platforms, I would recommend that you use things like CI/CD. So out of the box, native image builds for a specific platform where you're building your application, but you can use things like GitHub Actions. I'm a big fan, and there you can set up your builds for whatever platforms you might need. With that, let me click all the way here. So if you want to get started, the #1 place, if you want to take a photo or see where you can get started with GraalVM, you can go to our website. You can use GraalVM. You can just pull our container images or use SDK-man as you should. I highly recommend SDK-man. And if you want to try the demos that I have showed to you today, you can pull them from GraalVM demos, or you can just use my personal GitHub page where I also have all of them. And if you want to follow up or ask any questions, I will be here for the rest of the day. Or again, you can talk to me on social, and I'll be happy to answer your questions. With that, thank you so much for coming, and please rate this session. Thank you.